Hello, everyone. Thank you for attending and giving me the opportunity to speak to you today. My name is ElJallad. I'm in Tower Semiconductor. I'll be speaking to you today about the sensors for the harsh environment. Many applications in the industrial, medical, automotive, and even consumer industries face harsh environment. The sensor used in these applications not only need to withstand the exposure to these harmful gases, chemicals, moisture, and high temperature, but also need to operate and perform and continue to monitor during these events. I'll go over our standard CMOS platforms available to develop environmental, radiation, and magnetic sensors, which are scalable in feature, highly efficient, ultra miniature, and provide cost-competitive solutions for these applications. We'll also go over how these platforms can be used for the COVID-19 detection, monitoring, and sterilization, and some of the development that we're working on for AI integration, as well as using IoT communication to the cloud. First, if you're not familiar with Tower Semiconductor, we are one of the largest semiconductor foundries in the world. As a semiconductor foundry, we do not make our own products, but we manufacture wafers that contain designs based on our customers' specifications. This means that we must provide best-in-class semiconductor process, and this is where we invest our R&D resources. We focus on RF frequency and high-performance analog, power management, imaging and non-imaging sensors, and MEMS. We also have good focus on aerospace and defense, as well as automotive applications. In addition, we provide two services to our customers. One of them is what we call TOPS, Transfer Optimization and Development Process Services. This will enable customers to port their existing IP to our fab for many reasons, including expanding their capacity or moving manufacturing from internal fab to external fab, or simply scaling manufacturing to high volume applications. The second service provide is design enablement, which help some customers in designing their own ICs if they don't have this capability internally. We have 7 fabs worldwide, 2 in the United States, 2 in Israel, and 3 in Japan. They range in their features between 6-inch up to 12-inch wafer size for 350 nanometer process down to 45 nanometer process nodes. For the harsh environments, we have developed sensor platforms that are well suited for these applications. Our customers are able to create environmental sensors using these platforms, which include temperature sensor, humidity sensor, gas sensor, and pressure sensor. Those have features include wide temperature operating range, which range between -50 degrees Celsius up to 400 degrees Celsius. They're robust against exposures to material that might degrade the performance. This is really important for open surface applications such as gas and humidity sensors, where the sensing element itself could get exposed to harmful chemicals and gases that can deteriorate the performance, reliability, and the quality of these sensors. They also have extreme sensitivity to humidity and gases such as carbon dioxide, carbon monoxide, ammonia, and common VOCs. You can also create remote IR thermal measurements such as contactless thermal guns. And they require no power supply, or some of them require no power supply, which are well suited for set it and forget it application and dosimetry, where measured doses of exposure of extended period of time that range between minutes up to years is important. You can also create sensor fusion with these structures, which means you can put multiple sensing elements on the same die to enable a more compact and small type miniature solution for your application. You can also use our MIMS capability to create unique structures to enhance the performance. Now, all of this is using our standard CMOS process with friendly material. And I highlighted in red the features that are well suited for the harsh environment for many of these industries. With these platforms, you can also create radiation and magnetic sensors, include detection for UV, gamma, electrons, neutrons, alpha particles, radon gas, and other type of radiation. They provide ultra sensitivity and high temperature range beyond 150 degrees C. They are perfect as a reusable dosimeters for many applications that require continuous reading of doses of exposure in minutes up to years. They measure doses instantaneously. This is an advantage versus the current solutions in the market, which require sending the dosimeters to a lab to verify the exposure, which adds another step and adds more time to receiving the measurements. They also have wide range of temperature operation from -50 degrees C up to 400 degrees C. For magnetic sensing, you can create Hall sensors, TMR, AMR, GMR sensors. The magnetoresist type sensors provide higher sensitivity than the Hall sensors. These sensors also have wide temperature range operation from -50 degrees C up to 400 degrees C with high sensitivity. Again, all of these are using standard mature CMOS process that we have developed at Tower Semiconductor. One more time, I highlighted in red the features that are well suited for the harsh environment in many of the industries. So what makes our platforms unique and versatile for the harsh applications is that they are based on friendly, mature semiconductor process. The first platform is a GaN-based platform. You can create temperature, humidity, gas, pressure, Hall, and UV sensors with this platform. These are aluminum gallium nitride over gallium nitride devices with custom epistack. GaN is typically associated with power applications, which require the higher thickness for the epistack to meet these power requirements. But for sensing application, there's no need for such epistack, and that's why we created our own custom stack for these applications. Since they are based on GaN, they provide efficient isolation, or they provide efficient operating up to 400 degrees C. GaN is inherently robust against chemical reactions, which makes it well suited for open surface type sensors, such as gas and humidity sensors. GaN is also less expensive than exotic materials used for competing solutions to provide similar operating range. These materials, such as platinum and titanium solutions. GaN also provides faster response and recovery time versus standard silicon sensors. Since you can create multiple sensors using the same platform, this would enable you now to create multiple sensing elements on the same die, or sensor fusion, which provide many advantages, such as provide a complete solution for chemical and gas sensing for first transponders as an example. And you can see on the bottom some of the pictures of the applications that we have seen in the market and used using our platform. The second platform is our floating gate platform. You can create radiation, temperature, humidity, and gas radon sensor using this platform. This is based on Tower patented single poly flash non-volatile memory. This particular platform requires no power during operation, and actually no power during monitoring in particular, which makes it well suited for set it and forget it dosimeter applications. It holds a charge over an extended period of time at high temperature above 150 degrees C without leakage. These are rechargeable and reusable since they are based on flash, which gives it an advantage over one-time usable competing applications. They have fast readout and provide high accuracy. We have measured 64 distinct levels using these transistors. You can also use a single sensor or a single transistor or cell to create your sensor, or you can put together an array of these cells to add more accuracy to your sensor. And again, technology demonstrators are available if you're interested in evaluating these type of sensors. The applications for these sensors, we have seen them in the sterilization, for gamma sterilization, as well as for X-ray badge monitoring that's used in hospitals, for nurses and for doctors. The third platform that we have is the SOI, silicon on insulator. These sensors typically operate in the subthreshold region, which result in very high accuracy or sensitivity. So you can create remote IR temperature sensing with these sensors or thermometers. You can create gas and radon sensors as well as magnetic sensors with this platform. You can also use our MEMS capability to create unique structures to enhance the performance of these sensors, such as onion etch technology, as well as electrostatically formed nanowire or EFN, or resistive heaters or membrane. All of these can add and enhance the performance of these sensors. Again, we have technology demonstrators available if you're interested in evaluating this platform. Many of the applications include contactless thermal measurement, motor controls, smart metering applications, as well as white goods. In the past few months, our lives have been upended on a global level by the COVID-19 pandemic. It has been a test for us globally on both personal and business levels to overcome and adapt our behavior to combat this virus. This pandemic has heavily stressed the supply chain, the development and manufacturing of all industries without exception. It has also surfaced a few areas that can be improved and modified. First area I'm going to touch on is no contact temperature testing. This is, you can use IR temperature sensors or thermometers in this application. Typically, those thermometers are used in hospitals, but because of COVID-19, we have seen them used in building, room access, accessing lobbies, accessing companies, accessing restaurants as examples. Also, they can also be used at homes. And I have no doubt that these type of thermometers, we will see them in smartphones in the future. The second area is testing for virus infection. Because we have open surface platforms that are used for gas and humidity sensors with robust capabilities, these same platforms can be used for biofet and biosensor applications. This can be developed for fast and expensive tests in the point of care as well as home testing kits applications. Treatment and hospital environment in general. To provide continuous medical care, hospitals typically measure the CO2 and oxygen levels before, during, and after the infection of COVID-19. And you can use our gas sensors for these type of applications, as well as there is a high need now for X-ray, for chest X-rays as well. And you can also use our X-ray dosimeters for the badges are used for hospitals, for doctors, for nurses, and during their work against this virus. Another area that's been seeing a lot of hype for is UV sterilization. These have been typically used in the past in the hospital or the medical environment to sterilize or disinfect medical tools as well as hospital rooms. But recently, they are used for commercial applications such as restaurant and hotel rooms to disinfect the premises before or after the opening or usage of their facilities. Also, we have seen a rise of on-the-go type UV sterilization products to sterilize personal items such as smartphones and keys, wallets, rings, etc. Another type of sterilization is industrial type of sterilization using gamma irradiation. This is typically used for medical, pharmaceutical, and food industries. So this is and the last step before this product go on the shelf and be ready to be used and consumed. If you're interested with further information about this and our disruptive technology for this application, I wrote a blog that was published last month about the details and advantages of our dosimeters versus the current solutions available in the market. The last area is air quality monitoring for social distancing. You know, we have seen that the air quality using gas, humidity, temperature, particle measurement, and magnetic sensors in indoor, commercial, residential air quality system and ventilation control. Typically, these are used for measuring the CO2 levels in a room or a conference room, and then after reaching a specific level, then ventilation will be invoked. But since COVID-19, will these controls change to limit or control the number of people inside a room, inside in a lobby, as an example, as well as are there new regulations going to surface by some of the consortiums and some of the societies that are involved in these areas. As a summary, Tower Semiconductor provides best-in-class versatile CMOS platforms to design various sensors for the harsh environment. This includes radiation sensors, environmental sensors, and magnetic sensors. Those are based on mature, friendly CMOS process without adding any exotic materials. These sensors operate at high temperature. They're robust against harsh exposures. They support sensor fusion. They are IoT and AI ready. They're ultra small. They're competitive on cost, and they are ready for high volume manufacturing. These processes are also suited for many markets, including automotive, industrial, medical, and commercial applications. And we have extended support available to help our customers with their designs. This includes IP library available for ASIC development, process technology demonstrators, technology and R&D process team that's available to support the development of these sensors, as well as internal and external design support or resources to provide ASIC or IC design solutions. With this, I end my presentation, and thank you for your attention.